let's get back to this then. And I think where we are going to start is just to jump in and get my feet wet. We're going to fix another bug with the shell. Specifically, yesterday we did a bunch of work on shell input control characters, right? Being able to do read line operations like control P and control N, being able to do moving back and forth. We fixed some bugs relating to when I was re-rendering. I think we made some performance improvements as well. And today, what I want to solve is if we go into a read line application, if you hit Control C, it bails you out and you get a new line. Even if I've got some text in there, I can hit Control C and it bails out. It looks like Fish doesn't do that, but I want to duplicate that read line behavior. I don't know how much I care about it actually printing at Control C there, but I do want. I'm actually kind of curious to know, because I know the TTY on Linux can tell the kernel whether it wants to get control characters or not. I wonder if it's actually reading this control character out of the input or if it's getting a signal, and we can test that out by just doing strace bash, and I want to see if I do Control C. It looks like, oh my goodness, it's just doing all kinds of stuff. All right. Oh my gosh, bash. Well, if we use sh just for a second, see, sh is doing less stuff. Sh actually gets the SIGINT and then just writes new line. And the Control C character is there, and it looks like that's written by the TTY system, which is not really what I would have expected for a control character that is actually handled. But we could duplicate that behavior if we wanted to. But it looks like at least sh, the Linux, the Bourne shell, the basic one, is actually getting the signal, and I'm happy to keep that behavior. So if we look at, obviously we're going to have to do something in readline. Specifically, what I want readline to do is I want it to print a new line and then print, clear the buffer and print a new, probably just re-render, which we'll call print shell prompt, but it's not quite clear line because I just want to print a new line and then be done. So I think it's a new function. We'll call it well, we probably shouldn't put it between these two. Not clear, but kill, not bail, delete. Interesting point as well. So let's think about where this is going to get called from. This is going to get called from here in our signal handler. So Really, this should be SIGINT handler. It should not be a generic signal handler. Yeah, and I even have a to-do there to do exactly this. So that seems reasonable, maybe, but no, that's not what we should do. Yes, we should have a function called that. What we should do in SIGINT handler is just do something like got SIGINT equals true. Because we don't want to risk. We want the signal handler to be as fast as possible. We don't want to risk it like tearing or anything. And in fact, POSIX would tell you, and the C standard would tell you that the only safe thing to do inside a signal handler is touch a sig atomic t variable. Or I guess the C standard would tell you the only thing safe to do is touch a sig atomic t. I think the POSIX standard broadens that definition and adds a couple more things. So I think the first question here is, do I even have sig atomic t? And the answer appears to be yes. Yeah, apparently I do. Did not think I did. But apparently I do. And so what we're gonna need readline to do is check that every time it returns from read. So we still need a well, we might need a function for this, but we're not actually gonna use it just yet. What we're gonna do is so we have to get back into this function somehow. And the next question, I guess, is how? Because yeah. So the answer is that it gets restart sys, that the signal causes the syscall to return with restart sys. I actually don't know if that's. I'm gonna write a little test program to see if that's sort of standard behavior or how much, because I don't think I really have a way to do that right now in my kernel. So this could potentially be really annoying. Freed buffer. Let's just make a buffer. I don't care how big it is. 1024. Read from standard input. We're not going to do anything with that. What we're going to do is just on the next line, we're going to pr fread, and pr is going to tell us what the error number is. So what we will discover from this is that I can't do that. If I run test and then I hit control well, that's not what I want. I want to change the signal behavior, because if you don't register a signal handler, the signal will kill the process, which we don't want. I just want the signature of a signal handler is void return integer parameter int signal. And where is that? Signal.h. Signal.h. Signal sigint signal sigint. So the read does not return, and now I can't kill. Well, there we go. Oh, of course, because the strace detaches if you give it a sigint, which is kind of inconvenient. I guess we'll have to just use two processes. So we'll have test running over here, and then over here we will look for test. Test is this process, and we'll strace that process. Operation not permitted. Okay. So now, if I say Control C, read does not, in fact, return. It gets e-restart sys, and if I didn't want that behavior, I would have to change the signal call. And how do I do that? Sig handler T. Sig action. Sig action. So sig action, struct sig action, old. Sig action is a handler. Oh my goodness. Sigint. What is what is, I don't care about siginfo, we're not going to deal with that. If action, the action is installed. If old act is not null, the previous action is stored in old act. Sig num. This is anything except sig kill and sig stop. Yes, we're not dealing with SA restorer. The question that I want to ask is mask specifies a set of signals that should be blocked. Which I think during the, how did the signal mask of the thread which the signal handler is invoked during the execution of the signal handler. I don't know. Let's just do them all. 4, 5, 6, 7, 8. And this is a sig set T, so who knows how many bits it is. SA flags, though, this is what's going to be interesting, because the thing that we want to do is we want to set SA flags that do not include maybe the answer is 0. SA flags, is there like a default? Essay no CLD stop if signum and sigchild do not receive notification when child processes stop, i.e. when they receive sig stop, sig t stop, sig tt and sig tt out, or resume, i.e. when they receive sig con c wait. This flag is meaningful only when responsible with sig child. That's definitely not behavior that my operating system supports, but we'll deal with that another time. If signum and sigchild do not transform children into zombies. See, wait, this is only blah, blah, blah. What does that even mean? Interesting. Essay no defer do not prevent the signal from being received within its own signal handler. Don't care. Essay on stack call the signal handler on an alternate signal stack. Not interested in signal stack. Reset hand, restore the signal action to the default upon entry to the signal handler. This is only meaningful when establishing a signal handler. Essay one shot is an obsolete non-standard synonym for this flag. Essay restart, so I guess that means you get one. The signal comes in once and then it automatically gets reset to the default action. Say restore, not intended for application use. This is USD libraries to indicate an essay restore field in case of signal trampoline. Csig return for more details. And say essay restart and sig info. I don't care about sig info. So I think the answer is actually that I want flags to be 0. And so so sig action then is sig action sig int action null. Nope, definitely don't want that. And now, there we go. Okay. So now if I send an interrupt signal, fread says interrupt this system call, but the default is not to do that. The default is to have SA resume on. And this is not something that I can currently support, I don't think. I might be able to sort of hack it. I wonder, like, so where does that block actually happen? Sys read, I think, is where the block actually happens. Yeah. So so the way this is designed to work, file ops read is the internal function that is called by sysread. When you want to read from a file, that file, right, you get the file descriptor is passed to sysread. Sysread uses the file descriptor to look up the file and to look up the open file descriptor data structures, all of the information in the kernel that talks about, you know, where you are, what file we're looking at. And then in file, we have a struct called ops that contains all of the like function pointers for, oh, well, what does it mean to read from this file? So file ops read is the function pointer inside the file that says how to read from that. And the design decision that I've made is if this read function returns -1, that means that this read function is interested in blocking the process. It wants to wait for something else to happen. So what I say is if there's no data available, while in fact there's no data available, if it's non-blocking, then return E would block. If the underlying data, if there's no underlying data and the file has said that it wants the next read to be an EOF, then return 0, which is an EOF, right, from sysread. If you return nothing, that means end of file. And then wait on the file's read queue. And if you get woken up before that read queue, you end up needing to go back on the read queue, right? So there's a whole bunch of logic in kernel thread that deals with who, right, if you wake up and you're still trying to wait, then run the signal handlers and go back to sleep so that you can be awake for this, or sorry, so that you can be asleep for this, which I think is really, I mean, it's nasty is what it is. I mean, this sort of all comes down to some of the changes that I want to make structurally elsewhere. And I was thinking that this would be an easy change, but it's sort of led me back to the queuing and mutex changes that I want to make. So maybe we'll start hacking on that, and maybe that would help. I mean, there's potentially room for a, like, if I don't even know how you would check this condition. If the like, you know, imagine if running thread just got a signal and file has no data, right? Then you could imagine saying, okay, he restarts this. But part of the thing that's going to be annoying about that is getting off of this wait queue, and what if I would have no way right now to check, like, if there was another thread currently writing to this file and it just hadn't gotten to the point where it would wake you up, and now you've moved, like, that pointer is not going to be valid anymore. So I think we're actually going to put this down. Well, okay, not necessarily. We're going to put down the idea of doing anything with eRestarts this, but the thing that we decided was the default behavior on Linux is also exactly what I'm already doing, which has nothing to do with this. That was that well, I mean, I guess that's an interesting question. Are we still going to hit the same problem? I have to get back here if I want readline interactive to print out my new line and say, you know, hey, you fucked up. Go to the next line, give me input again. So I have to get this read call to return somehow. Or no, yeah, there's no, because this is all local state. So it's not like yes, all of this state is still valid, but I'm not gonna have the signal handler reaching inside the local variables of this function to change these parameters, to change the cursor and to change the, so what I would really want to happen is I want the signal handler to set, hey, you know, we got SIGINT, we should really, you know, we should try this again, and then I really want read to return. Which really this should be fread too, because I'm not supposed to be using the raw read call, but that's a whole different problem. So that's kind of annoying. Well, I mean, where are we on these synchronization primitives? How much is left to do here? So I should really go to the include file. Nope. Right, because we're using WQ. We've got semaphore here, but it looks like we never wrote any functions for it, so presumably that's not actually used for anything. It would help if I quoted that. It is indeed not. So we could just get rid of that right now. And then wait queue and convar, which convar is literally just a wait queue. And what? It's literally just a wait queue, except it also it also tries to do this atomic stuff, which then I'm not really sure why WQ block on, because block thread, why am I copying this from, I guess I'm copying it from block thread so that I don't have to call block thread. Yeah, this is all kind of, especially because convar and waitqueue are literally just the same thing, right? CV wait is, with the exception of the mutex guard on it, which is just matching the pthread mutex API. And I don't really know if that's getting me anything as far as synchronization in this context. But we have the mutex, and then signal is just notify one, and broadcast is just notify all, and wait is just copying from block thread, which is called by block on. Like it's just the same thing. So here's a question. Preferably we won't have that at all. That's already in basic. Let's say that hypothetically we were to redo this entirely. How much is WQ used and how much is convar used? File system, and that's it. It's actually only used in file system. And then convar, coinvar. Convar is used in sync test bed, and that's it. Okay. So that's certainly very interesting. And why are these any different? I guess the difference between this and a mutex is owned, where these are just like, it's not an ownership relationship. It's just, this is a set of people that are waiting for an event to happen. when that event happens, I want to wake one of them up. But that's pretty darn similar to, like, I should be able to just do this with all of the same primitives as the mutex stuff, right? The only difference will be, instead of this atomic fetch add, or sorry, instead of the atomic compare exchange in try lock, it will be it's just basically it's just the wait on code saying, you know, this is my ticket, I'm waiting, block. Like, it might be exactly the same, except for this function signature. But I wonder if I could, like, use the same data structure. Because then wake awaiting thread would be the exact same thing again. It's just there's no lock, or the lock value is not useful. Let's try it. Let's, like, literally that's just going to be completely empty, and we're going to go to sync.h, and the thing that we're going to do, we're going to get rid of all of this. We're going to have to rename these structures globally, obviously, because I can't pound define struct WQ, the pair of words. That's just not how the C preprocessor works. But I'll be happy to just rename those wait QT and convar T, and then struct WQ, well, okay, not %s, hey, so for all of these, struct WQ becomes wait QT, hey, so for all of these, struct convar becomes convar T, convar becomes convar T, and then we're going to define actually, that's not even true. I don't care about those at all. Well, I mean, I care about them long enough that I can read it. I never used notify all or broadcast, and it would require an additional function to be written, but I'm not going to write it because, no, I definitely did use it. We'll come back to that in just a second. That should be pretty easy to handle now anyway. We're going to define a WQ init, a new mutex init, define WQ block on to, and I didn't actually put these public, and I made them static, which is not helpful. Wake awaiting thread and wait on a new mutex. I should just copy these. Wait on new mutex and wake awaiting thread. Copy, paste. copy those again. Not here, but sync.h. Not for this, but so that I can remember which one is which. Put that over there. WQ block on is wait on new mutex. WQ notify one is awaiting thread. And then there are convar functions for the same thing, cv wait and cv signal. And then cv broadcast and WQ notify all is indeed used. So we will just have to make a quick new function called wake all awaiting threads, which doesn't make a lot of sense for a mutex. If no waiting, there is no deli ticket stuff, and awaiting will always become 0. There is no winning thread. Instead of saying n-awaiting plus equals 1, we say th to state is running, ts running, If there's nobody waiting, return for every thread. If the state is not TS block, continue. If the awaiting mutex is not this mutex, continue. State is running, awaiting mutex is 0, and enqueue the thread. Okay. And now we can say WQ notify all. Wake all awaiting threads. And ditto CV broadcast. Broadcase. We need to put that in the header. Sync, not sync. New mutex.h. Sync.h. We delete all of this. And all of this. And now we have to find every struct WQ and struct convar, include, and replace them with wait QT. Not include. Struct convar is convar t. And that's a good sign, okay? No member named th awaiting mutex in the struct thread. Did you mean awaiting new mutex? Yes, indeed, I did mean that. Yes. Okay. So that's a new and different and interesting problem, which is that CVinit doesn't work anymore, and I need to initialize them with a function, which should be fine. The only real... No, it should be fine. It's going to be a tad annoying just because I think there's several paths that can make a file. So, for example, just right off the bat, VFS init is going to have to call that on all of these things that exist already, presumably for both read and write queue. Right, so dev0, dev null, all of the dev serials need to have those initialized. And we're doing it for WQ, and maybe that's fine. Actually, maybe that's fine, because I already had to do that for WQ. Let's make sure that sync has a cv init new mutex init. Let's see if this builds. I presume it will. CV wait. Okay. Yes. So that's not... So, okay, so this function is not literally the same function. And honestly, I think what we might do is just not use convars right here, because that's going to be kind of annoying to fix. Hello, Omer Yusta. Sorry. Nubian C wanted to know, is it possible to make size t const? Home file gets parameters as size t but not const size t. Is there a reason for that? Yes, there is a reason for that. We were looking at FSFS, I guess. You mean stuff like this? Like, why is this not const, right? And the reason for that in a function parameter is that, yes, I totally can make this const. And in fact, I don't think that would change this particular function at all. But it also kind of doesn't really make a difference. Right, this length is already a copy of whoever called it. So if I was to go in and start editing len here, in the best possible case, it would sort of not matter, right? I could say like, oh, len, oh, it's 100 less, and they would just read 100 less. This isn't like edit the caller's value of len. And in some cases, I use that, right? I want to be able to change the parameter just like it's another variable. So like if we went to a different read, I know my my read in the standard library, the f read, the like user facing read, something you can do with file streams in the standard library, which is sometimes helpful for parsing, is you can put a character back. If you read a character, you can unread the character. And so if I'm reading and there's a character that's been unread, I just put that character in the buffer and then say len minus equals 1 so that the rest of the whole function behaves as though they read one fewer character. Elections for just understand, they won't touch it. Yes, like I think you're right. There's definitely a case that I could. It might be better to document, right? To say like, hey, you know, we're never going to touch n, so this is const. We're never going to touch count, so this is const. It just doesn't. It doesn't really make a difference. Right? Const doesn't really mean much in C. It's really just kind of documentation. You can write through to a const variable if you want to. I mean, you have to cast, but you can just cast. So it's not like, yes, I could do that, but I think it's just not very common in C. I think it's much more common in a language like Java, where the ecosystem, the entire community is sort of oriented around, you know, this is a public and this is a private, this is a final and this is not final. I think it makes more sense. But here, I don't think it's worth cluttering up my function, right? Because this would be, well, buff I do have to write through. Well, I could say that this is a constant pointer to void and const size t and the file of the stream is also a constant pointer, but that sort of doesn't add any information. And yeah, yep, it's totally possible. All right, so sorry that was too roundabout there. And we were looking at the sync test bed because CV wait turns out to not have the same signature as the wait queue functions, but I suspect that this will be fine. It is fine. The question is whether this works literally at all. And synchronized does not equal, that makes a lot of sense. So we're just going to not assert this, because it turns out if you don't wait for the... No, don't worry about that. You did not waste my time. No questions are stupid. No question is a waste of time. I appreciate it. Okay, so that seems to have worked. The sync testbed didn't work because condition variables have a slightly different signature, but the thing that I would need for this is my wait queue to work, right? The wait queue, because this instance of Rot13 is going to start immediately. It's going to try to read from standard input. There's going to be no data on standard input yet because this hasn't run. And so it needs to be woken up after the fact, or else it will never read anything. And so the fact that this is working consistently makes me think that it's probably working completely. We can always really figure this out by s-tracing the whole pipeline and getting a crash. That's entertaining. Oh, because I didn't. Helps if you specify a program. I should probably fix that. That if you say s-trace -f, I think the check-in s-trace is if there are no arguments, then don't try. But this is an argument, so now it's trying to run the program null. Or specifically, it's trying to print null, presumably. That's really entertaining. We'll have to look at that in a minute. Hello. That's fine. So route 13, and what do we end up with? We end up with exec v hello in presumably process 8, because that's where it goes to next. The mmap. Then we run process 9, exec v route 13. That tears there. So this PID comes from, oh god, it's all intermixed together, so it's kind of difficult to follow exactly what's going on, but I'm trying to find the read call. Here's the read call. Yes, okay. So this has answered my question. My question is that the read call is in fact happening after exit in the parent process. So I think that means that it is work, and that's good. That's a little bit concerning, but let's, oh, that's actually, do I commit this now? Like, am I, oh, I didn't commit the last thing that I did. Earlier I was working on the event log and I did a bunch of stuff on it and I didn't commit it, which means now I don't remember which files are related to the event log and which files are related to all this mutex stuff. So let's try to figure that out. What's left? Syscall is event log, thread is event log, and I think that's it. Syscall, thread, sync and sync testbed, new mutex, sh, sync, new mutex fs. Wasn't there something else? I think there was one more. I guess not. Event log. Earlier we made it so that add optional event printing with format arguments. And then this is WQ becomes wait QT, wait on new mutex, wake awaiting thread, wake all awaiting threads. We get rid of the things in sync. We made those not to be static. We need to get rid of this line in wake all awaiting threads. We deleted everything in sync. We changed these. I'd like to fix convar before I commit anything to make sure that it works in the sync test bed. And then the SH stuff we're just gonna kind of chill with for the moment, I think. So, and we'll just leave it there. So, a condition variable is you've got two of these. How does this work? How did I have this before? That CV wait, disabled IRQs, unlock to this mutex, set blocked, right, and then when it returns from being blocked, it locks the mutex. This is, I never remember how this works because I just take this logic, I took this logic out of pthread, the multi-threading library on Linux, so I I don't really know. I'm just going to duplicate this behavior. And I think all I really have to do, we're just going to call that something else, mutex unlock mutex lock. I think that's really it. Because everything else should be the same. So maybe we should like factor these, right? That we make this just call with null, and we'd say if that seems reasonable to me. And then we'll document why this exists. Alternate form to operate as a convar. Well, seeing if we can use the same guts for both. And then in sync, CV wait becomes wait on mutex CV, and CV signal I don't think needs it. Maybe it does need the does CV signal need the no, CV signal does not need the mutex, so who really knows why it's there at all? I don't remember. And that should be good, hopefully. ID. It's not called new mutex, it's called convar now. It's not in the header file. Makes us rebuild even more things again. All right, that built, and our test bed passes. So A/B test works. So, oh, that crashed. Don't know why that crashed. We may never know. Out of memory test works. We can view the processes. Don't know what that even went to. Viewing that sort of stuff seems to work. What did we say? It was Control O. A/B test in the background. View processes, kill. A/B test process, kill. A/B test process. Go back over there. Still working. All right. I guess we're gonna commit this. I didn't really expect that to work, but you know, I'll kind of take it because I've been trying to get rid of these things anyway. So place wait queue and convar with new mutex. It seems the inners are flexible enough. How bad could it be? I wonder if I can get rid of the wait node now. Because so the way these things have worked in the past is I use what are called intrusive lists for storing things like what is waiting on a particular file. And so that's a list where the pointers are sort of interned within within the structure. So this is the thread structure. This is the structure that represents a single thread of execution, a single user mode. Yeah. How bad could it be? The thread represents a single like user mode thread of execution, right? Basically a single process, right? The shell is one of these threads. And so when I store, okay, these 5 people are waiting on this process, that's this wait node is actually the storage that is used to store that information. That the file has a pointer to the thread, and then in this wait node that has a pointer to the next thread that's waiting, and then that wait node has a pointer to the next one. And because you can only be waiting on one thing at a time, because you know if you're blocked not making forward progress, you can't be doing something else. So that works, that you can just use this field, but there's a bunch wrong with that. I mean, for starters, look at this compiler error that I got just a second ago. I think this is for 1. It may not be for 1. But just like, look at this compiler error. This is awful. I hate this. I don't want to use this anymore. This is terrible. So the thing that is currently called new mutex, which will eventually just be called mutex, uses a completely different system. It's a little less efficient, but it's a lot more not this. Right, because what is this telling me? Well, this is telling me that on line 568, yes, this doesn't exist. But then on 860, oh no, okay, list removed. So yeah, so this is 1, and this is the second instance where I have wait node, and this is fine. We can just get rid of that. but then it's these that are inside, assertion, but then it's this like, okay, well, list pop front is deeply inside of all of these macros, and then list for each is even more macros. So we've just got to find all the instances of wait node and comment them out for the moment. If I is thread block IRQs disabled, should that be called after the mutex or while it is still unlocked? That should be called while it is still unlocked. That's in the right place for now. Because the idea is you come into this function with this mutex locked. The function unlocks that mutex, puts itself to sleep. So this thread is now asleep, waiting for something to happen, and that mutex is still unlocked. And then it only takes the mutex back once the event has happened, so after this wake up has happened. And that's the same, it's the same behavior that I had before, when the function was a lot shorter. Say mutex unlock, block with IRQs disabled, and then lock it again. This has some... This is like the example of this. I can't really explain why this is necessary very well. This is the example of this that you get when you look for the pthread, the pthread examples, right? So I'm locking the mutex. I'm immediately unlocking it to wait on the condition variable, and then I'm immediately locking it again. There is some reason to do this that is related to consistency across when you have multiple threads waiting on multiple condition variables. I'm doing it because pthread does it. Maybe it will come back to bite me later that I have a quote-unquote wait queue that doesn't have this same behavior, but for now, this is what it is, and I'm not using it for anything except this test bit, so I'm not too concerned about it. Does that answer the question? Wait node. Yeah, it's pthread convart signal or something. Do I have pthread manual at all? I apparently don't have the pthread manual for some reason. Why don't I have the pthread manual? That should be there. It's a super interesting field, right? The only reason that this project has lived so long for me is that there's always something different to do, right? I mean, you can see there's however many different files, and that's just in the kernel itself. So if I'm sitting here working on mutexes, if I get bored, I've got like all kinds of different stuff that I could go do. And I've got all kinds of different to-dos all over this. But and it's actually been it's a challenge because, right, you always want to have really good code, you know, you always want the code to be really, really pretty and really good. And a lot of this code is old and bad. And so I have to like figure out how to keep working on stuff without getting too upset about the fact that some of this code is old and bad. Because I will just never make any progress if I'm sitting here rewriting the bad stuff that works. I gotta fix the stuff that doesn't work. So, wait node. It's just all in kernel thread, wait node, kill that, in thread exit, that's not there at all. Block thread with a list of blocked threads. This should just never, yeah, it's just never called anymore. So, so let's just comment this whole thing out. Wait node, wake thread, assert this empty wake node. Well, that's not really necessary, and that shouldn't be. Wake thread shouldn't be called either. It is called. Oh, wake q1, wake q1. These shouldn't be called either. Multi-threading or multi-processing? Well, I mean, certainly depends on whose life. The kernel developer is probably more upset about multi-processing than multi-threading. I mean, as a anecdotally, this kernel definitely supports multi-threading. You see, right? I've got a thread file with a whole bunch of stuff in it. I do not support multi-processing. That's a lot more work to go through all of the hardware crap to find other processors and turn them on and get them running something useful. Multi-threading, when you're in the kernel, really the kernel is basically just a single threaded thing that's jumping around, right? I'm simulating multiple concurrent threads of execution for user mode. So as far as the kernel is concerned, it's basically just one thread, where as soon as multi-processing comes in, you know, now I've really got hardware doing two things at once. I've got to be worried about who's writing to my memory everywhere, which is part of why I dread doing it, because I haven't been worried about it so far. So I expect it's going to be really nasty when we get there. But I do expect to do it, and I'm hoping a lot of the work that I'm doing right now, all of this stuff to get rid of all of these pointers and get rid of these lists, this is all in service of, I want to have the ability to audit my multi-threading and get it right, multi-processing and get it right. And I don't have any confidence that I could do that right now. Hello. Spurious? Because I wasn't ever using wait node, so I don't think that's actually related. These are just test programs. So this one is, you can see clearly, making lots and lots of different threads and processes. It's doing all kinds of crazy stuff, and if you let it run for a while, it helps me validate that there's some consistency in the system and that it's not going to do something like this, where here, right, this is a panic. we tried to schedule a thread where the data structure was wrong, right? The data structure, the magic number in the data structure was not the correct magic number, which could be, I mean, there's any number of reasons why that could be. Right, there's all, this is not intended to like reproduce specific bugs. You can see, again, this is like ridiculous junk. So this was probably either it was a partially initialized thread that we tried to run, or who knows. But the thing that I'm trying to determine is there any... see, this has now happened twice. I don't like this. This is new. I don't like this. That's suspicious. That's really suspicious, actually. So what do we got here? This is another crash. We had an unhandled exception. We can figure out where this was. Was it? Yeah, okay. So this was in syswrite. So presumably this is the shell trying to print out, either trying to print out its prompt or something else. And we got a general protection fault, which with error code 0 probably means we accessed a pointer that was invalid. And suspiciously, right here in our registers, there are 2 pointers that are invalid. So I think the next thing I want to find out is where precisely is this. And this is like caused knock-ons, so we're going to do a little bit of editing. Do I use a static analyzer to test my code? No, I don't right now. I've thought about trying to set one up, but I have never actually got there. So we're going to just delete all of the knock-on effects there so that I can use my really fancy dumper to tell me exactly where it went wrong. And the answer is fs.c on line 237, and as well, before we do that, we're just going to quickly also check the specific line. So 801.15967, right? That specific address corresponds to this assembly instruction in file ops write. What is that assembly instruction? Well, it's reading from RBX. Remember I said, suspiciously, we have an invalid pointer in RBX. So I think that might be the problem. But why? Why do we have an invalid pointer in RBX? Syswrite fs.c, we came up with the answer and then I forgot it. .a 237. That is not the right file. 237, which is just straight up and down return file ops write. And which do I have it? Yes, I do. No, that's not right. I want this number again, the address of the instruction that faulted, so that I can go to the instruction that faulted, and we can try to figure out what's in RBX, if that's going to be easy. Which it looks like it's not going to be easy. Right, because this is all kinds of nonsense. FS node boiler is awful and terrible, and I really dislike everything about this file system code at all. But FS node boiler is finding all of these important things. So it takes the file descriptor, and from the file descriptor, well, it looks in the running process and finds the open file structure. If that doesn't exist, then it's not a real file descriptor. If the permission doesn't work, then you have a bad permission, and then it finds the file structure from the open file structure. So somewhere, not necessarily somewhere in there, but somewhere related to there and related to here, it's ending up with a pointer. It's reading a pointer at a 1 byte offset. So you're ending up with an invalid. That really doesn't sound like fun. I've never seen this happen before, which is why usually I would just write that off as like a random coincidence. But I saw it happen twice, and I've never seen it happen before. Yeah, see, there it happened again. How reproducible is this? So there, we had it happen once in a couple of runs. That's just a crash. That's another crash. All right. Yeah, there's something wrong. What's the current diff? We're just gonna go ahead and stash everything that's currently diffed and try this again. I wouldn't expect this to make a difference. Yeah. Okay. Why are we not? We had one spurious crash, and now it's not doing it anymore. Okay. Can I stash a specific file? Stash. Apparently not. Save that. Git add dot git commit MSP git co-b temp git drop one, no, git co master drop one. Do I have drop one? No, I don't. Just making basically a save commit there so that I don't lose those changes, but I've gone back. So if I log all, I've just like made this temporary commit, and I've put the changes in this temporary commit, which is not right now. I'm pointing at master, and then what I'm gonna do is drop the stashes that I made, co temp thread and include, right? So I'm pulling some of those changes from that branch, but I'm leaving other ones in that branch because I want to see what caused it to start crashing like that. I'm kind of hoping that it was the shell changes. Right now it kind of looks like it was, which is a little worrying. Oh, no, it was not. Okay, so but nothing touches, like the wait node doesn't even exist anymore. Nothing touches it, and I didn't have to remove anything. I just commented out functions that aren't called. Is it literally as stupid as, like, there's an alignment problem if I don't have that there? Actually, I'm also gonna do a clean rebuild, because that's, as much as I like CMake, that kind of like, oh, you're off by one and I've just changed the layout of a structure, that could totally be that something is depending on it and like wasn't expecting. I would totally believe that. That something was depending on the layout and it wasn't getting rebuilt properly. I would totally believe that. I'm going to be annoyed, but I totally believe it. So how many times do we have to do this before we decide we're happy with it? There's a crash, but we get those all the time. That one we know. I'm really worried about this general protection fault. All right, so we tried two things there. So now we don't actually know what fixed it. We're gonna try getting rid of that. So that's gonna rebuild 30 things. If my theory is correct, actually, no matter what, if my theory is correct, the problem should come back, whichever thing caused it. Because if it's a thing that's not getting rebuilt, that wouldn't have been rebuilt, so it should come back. And if it's some sort of alignment problem, I've just put it back to the way that it was before when it was having the problem, so problem should come back. Watch it not. And that was one. No, it wasn't. This is a different problem. Or a different crash. It might have been the same problem. But it's a different crash. And it didn't take the whole system with it. In the same place. All right. Don't hold enter. This is that problem. Same one. So the answer to how many we have to do is like a lot. I know this is thrilling. I hate these like really random, like once every 10 times it's gonna crash. All right, so I think we're kind of happy that it's not happening right now, which would, I mean, that matches my expectations. So then the last thing that we have to check is if we do a clean rebuild now, if it's an alignment problem, the problem will still exist. If it's a rebuilding is not clean problem, the problem will go away. So, final series of checks. That's a crash, but that's fine. Stop it. I'm hitting Control up, which is putting the computer in expose mode. All right, I don't think it's happening. I'd really love to be able to solve that crash. And maybe I can. Maybe that's what we should look at. So I guess we're gonna call it good. I don't know. I think we're gonna say that we did it. I'm real spooked by that. I think we're gonna make a commit that says, well, we have to, let's get rid of all of this white space on the end of the lines. Hello, %s, space, $, to nothing, space, star, space plus, space back plus, $, to nothing, commit. Sure. I mean, I'd be interested to, if you've run an analysis and it's come back with something interesting, I'd be interested to see it. Yeah. Thread, remove all references. You should be able to post a link. I know that wasn't working before, but it should work now. Or however you want to do that. Rate node. I don't think base can ever be 0 though, because base is always set up here by font.format, right? It's always 10 or 16 or 8 or 2. So, and that's the only, right? If it's not one of those, you get a return -1. So I don't think it can ever be 0 at that point, unless something else edits base. I don't know. What did you generate this with? CPP check? Cool. Let's see what happens. Yeah, there's some interesting stuff in there. I see there's some mentions of like places that I'm assigning values and then assigning the same value again or stuff like that. Check. Oh, yeah, that just works. I'm used to because I have like bespoke includes and stuff, I'm used to these things all bailing out and dying and being really upset. Example of that was, I forget what I was trying to do. I know every IDE I've ever tried to import this project to, I've been like fighting with it just because I know it can be done, and I've gotten to the point that it works, but just the fact that I've got all of these includes that are not in the system directories, but I use the brackets because it is system, so stuff always gets mad at me. And I'm like, no, don't be mad at me. This is how it's gonna be. I think it might be interesting to see if we can find out what's going on with that crash that happens right on system boot. Because I think I might have a chance if we use the QEMU interrupt debugging, -I. And then, like for example, right there, when it crashed on boot. I should have been writing this to a file. Wow, I didn't expect the first one to do what I wanted it to do. But let's see if we can't get something interesting from this. We're gonna go ahead and save all of this first. Gonna go ahead and just put this in my in a text document over here so that I can come back to it later. And I wish I had, I guess I do have last output. So last output will tell us what happened. What happened was the exact failure that always seems to happen, that you get through and before it starts user mode, you just die. And what happened? Well, these are interrupts. So this is when the CPU gets either a message from hardware or an exceptional condition, like a divide by zero, the CPU raises an interrupt. This is not the same as an interrupt in a programming language. This is a CPU interrupt. And this is the emulator telling me about those CPU interrupts. So the first 500 or so are v equals 20, vector equals, this is hexadecimal, so this is the interrupt vector 32. Interrupt vector 32 is the timer. So this is the 506th time the timer is saying, hi, time has advanced. This is the 507th time the timer is saying time has advanced. And when that arrived, when vector 32 was asserted, the current privilege level was 0. The system was operating in the kernel. It was currently at instruction pointer this 801BFC4. Program counter is the same as the instruction pointer in this case. The stack was here, whatever. And these are the registers, RX through R15. Instruction pointer, which is the duplicated up here. CPU flags. These are various other internal registers, debug registers, and feature select stuff. So it looks like we had started user mode because, or at least we were working on starting user mode because CR2 is a register that contains the address of the last page fault. And CR2 is telling me that the last time there was a page fault, this is not a page fault, but the last time there was a page fault, it was in user mode. So it's at least working on getting user mode started, even though user mode hasn't printed anything yet, according to last output. We've only gotten kernel thread output. That is the same for the 508th, and it's the same for the 509th, but then the 510th instruction is not the same. It's vector OXOE, which I'm going to have to look up quickly to remember which one is OXOE. Exception, I think E is what, 14? That's a page fault. Okay, so this is a page fault. And it updates CR2, right? Previous page fault was 7FFF. This page fault is C174DFF8, which is very closely related, certainly, to the stack. It's either where the stack is or where it's going. It's very closely related to the stack. And I'd love to know where this happened, so we're going to grab this number. I want to... actually, what we're going to do, I'm going to open up tmux. We're going to open VI on the one side. We're going to take the copy that I've copied. We're going to paste it. And then we're going to split the screen. And how do I... And it's fine. So the thing that we want to know is, where did that happen? Why are we getting page faults? The answer is 8011F7C8, which is in new mutex lock. But I think that's a coincidence, and I think it's a coincidence because we're still in the function prelude here. It's just pushing things onto the stack, and I think this is telling me that the problem was caused by blowing the stack, that we used all of the stack for some reason, which is certainly suspicious. Why would we be using all of the stack that early? The fact that, yes, it's coincidental that it's in new mutex lock, but it could be because, like, this could be something like, oh, it's trying to take a mutex, and that mutex is, I mean, it's not literally going to be recursive, but it could be like, oh, the mutex is taken, so it's switching a thread on the same stack or something like that. I'm not entirely sure, but this is definitely telling me, right, we're pushing things onto the stack, and we're either not popping them off, or we're not coming back down, or we're calling switch thread or something. Unfortunately, I don't have access to that stack because the VM died, right? The emulator died and exited, and so yeah, I have this print output, but I can't actually look at anything that's not this printed output. And then, so we had that page fault telling me that the stack was blown. We then had another page fault, right? The reason that we died, a page fault doesn't kill the system, right? There's ways to handle that. But the reason that it died was there was a page fault, OXE, and then handling that page fault, because the stack was blown, we had another page fault because there was nowhere to put the code to handle the page fault. So we had a OXO8, which is a double fault, which is what happens on x86 if you have a fault and then you have a fault while handling the fault. You get a double fault. We had a page fault handling the double fault, so that's what's called a triple fault, and a triple fault reboots the machine, resets it. So, I mean, the thing that I should really do is I should get off my butt and implement I can have an alternate stack for double faults so that when you blow the stack, this doesn't happen, and that would allow me to like find out what's going on. So I wonder how hard it would be for us to just set up an alternate stack for double fault. I feel like that's probably not super hard, right? I mean, hopefully. Where is that code? It's in Arch x86, probably interrupt. This is where all of those interrupt handlers are registered. Presumably, I just have to tell it there'll be like a flag or something, right? Hopefully. I know where these stacks go, because I have the boot in the assembly code that I pass at boot. I have it's the task descriptor, right? That this has. No, this is the GDT. Yeah. TSS64 stack has these 4 stacks, and I suspect it might be like one of these. I'm not gonna spend interrupt descriptor. Bits 0 through 2 holds interrupt stack table offset. I suspect that tells me that if I just put like df stack here for double fault stack, and then we'll have to make that stack. Really care that that's global. So that's a double fault stack. It's aligned to 16 bits. It's 8K. It's probably super doesn't need to be 8K. We'll make it 4K. And then I suspect if I go to interrupt.c, where do I have handler low CS16 IST32? That's it. It's IST. And where does IST come from? It is just passed to raw set IDT gate, and I always set it to 0. Okay. So I think what I want to do is I want to just make that ist, pass that through, change all of these to have an explicit 0 in them, close parenthesis, 0, comma space, 0, close parenthesis, and then 14, 1. Now, how do I test that? That's a really interesting question. Let's see. If we get, maybe let's register like an interrupt 127 and call it ISR triple fault, ISR double fault. And it's definitely not user mode. Fault. Extern void ISR double fault. Oh gosh, because this is not ISR double. I don't even know if this is going to work, but the theory, the hope, the belief is that I can basically just call that. So I'll have, yeah, if, else, if interrupt number is 127, our double fault interrupt, so I want to say, like, did we do this before? And if we did, because I don't want the second one. No, I just straight up want this to say asm volatile int 127. Right, so that's the idea, is that we're going to have an interrupt 127 that while handling interrupt 127, it throws in 127. And hopefully that will trigger a double fault. I also put that in the wrong place. That should not be 14. That should be 8 is the double fault. And I should also, all right, so what did I do wrong there? 127. Do I have to do that? Is that what's wrong? Or do I have to invalid operand? I think I actually have to like put that in a register, because you can't, I mean, it's assembly, it's just awful. So I think what I have to do is like mob rax 127 like n back t int rax, no, because this is GCC 127 comma rax, put 127 in the register, int the register, we're hitting the register, we're corrupting the register. Unknown of a mnemonic without a size index, mov long. Invalid operand for instruction instantiated into assembly here. I don't remember how to do this. It's been too long. I don't spend that much time this low level anymore. And of course this is Intel syntax too, so it's not even particularly helpful. I have an example of this in syscall. Uh-oh. Let's see, syscall that I had to do this. Ah, percent, not dollar signs. Right, okay. So this is a dollar sign. This is a percent. And that's probably like AX. It's not Felix. I need to look up the instruction encoding for interrupt. Int. Because I don't know what it is. It takes one of the registers, but I don't know which one. It's a specific one. Int n is generate software breakpoint trap. What? It takes immediate 8. What are you saying that this isn't allowed? This should be allowed. Maybe it was just literally that I needed to interrupt $127. Yep, that was literally the problem. It was the dollar sign. Oh. What? But I made that. OSR. I didn't make it global. x86 ISRs. It's here. But I didn't make it global. So the symbol wasn't exported, so the linker couldn't see it. Now I have to figure out how to call it. And I think we're just going to make a little temporary control key. So kernel tty for the control keys. What's a good control key? What's a good control key? What am I not using? $127. Not make, but run, because I just need to find a control key that is not in use. Control Y is not in use. So if I type in control Y, int 127 in the kernel, and that crashes it immediately. Well, I mean, that's good, I guess. It means that I can reproduce the triple fault problem, which is an improvement, and honestly, I think we're going to commit that. Arch x86, add a double fault interrupt endpoint to a double fault interrupt endpoint. This And maybe we need to limit that to only 2. Maybe not. We'll find out. So let's do a run. With -I. And then once it's running, well, it crashed again. And it didn't move the stack pointer, so that's something, I suppose. Where is the interrupt stack table? That is not. Yes, I did not use the right field for that. So the interrupt stack table, that's not the right one. The interrupt stack table, in fact, I think this, oh, well, that's part of why. So it would help if I read IST0, IST1, IST2. So I already had it there. I just wasn't reading. And that's also not the 64 structure is, long reserved 0. This is called RSP0. This is called RSP1. This is called RSP2. This is reserved 0. But then this is not IST0, this is IST1. And this is not IST1, this is IST2. 5, 6, 7, 8. And there is no 8. It goes only to 7. And I'm not going to change. Part of me suspects that this might be wrong. The IO buffer, but I'm not using these anyway, and it seems quad and word. This is not correct, right? So let's count this actually the right way. TSS64, 32 bits reserved, 64 bits RSP 0, 64 bits RSP 1, 64 bits RSP 2, 64 bits reserved, 64 bits of IST 0 through 7. Sorry, not 0. 1 through 7. 2, 3, 4, 5, 6, 7. 64 bits reserved 0. Then this word. Yeah, I think I actually messed that up when I transcribed this from 32 to 64 bits. And then the word is fine. That still crashes. So I want to do -I, but the thing that's interesting about -I is it seems to crash. E AD 08. Oh, but it's like general protection faulting, which means that the stack pointer is probably wrong. Question. In freopen, you are closing stream and then trying to use deallocated stream again without malloc. Is it normal? I certainly wouldn't look at freopen as a smart function. I think it's not really the right thing to do. But in this case, it is fine. It's definitely not normal. It's fine in this case, and it's fine in this case because if you look at fclose, I actually just never free the stream. If I freed the stream, then it would be a problem, but I'm just reusing the same memory because I actually just never free it. And I never free it partially because I have a couple of statically allocated ones, right? Like I can't free standard out because standard out doesn't live in the malloc buffer. It lives in this, in the source code basically. So I would have to, I just currently don't. I don't have the required supporting infrastructure to be able to actually free these things. So it's, I wouldn't do it this way. I probably wouldn't do it this way if I was writing this again, but it works for now. Honestly, I don't know why it's not. Why am I not just using the same code from fopen? Especially because I've changed fopen without changing freopen. Yeah, that's just kind of bad. I should factor those together, but I'm not going to worry about that right now. I will put it on the to-do list. That's done. Go ahead and put that in long term, and then freopen in the short term to-do list. And let's, so as far as our stack manipulation is concerned, it's certainly not happy. I wonder if maybe I'm using the wrong bits or something. It's not happy. So before we were, yeah, please be happy to be, I am happy to answer any questions you have. So I'm glad to see that you are interested. Actually, what is this? Oh, this is doing, okay. There's a whole bunch of stuff going on here that I wasn't reading. So, yeah, okay. So for starters, we can note that, so 7F, right, that's 127. We note that there's 127 here and 127 here and 127 here. So we're definitely getting the same thing over and over again. But I think that's actually not... yeah, so what's actually happening here is that the stack pointer is moving every time. So we have 7F at stack pointer 14B360, and then we have 7F at stack pointer 14B250, and then we have 7F at stack pointer 14B140, and then 14B030, AF020, AE010, and then we get a D, what's a default? D is a general protection fault because we're like running out of stack. We're trampsing the stack more likely because we're passing the boundary there. So I'm not actually getting a double fault out of that. I'm not actually getting a double fault out of that. Because it's not an exception, I guess. I don't fully know how that works. But I think we may want to pick a different... We may need to pick an actual exception. We could try 9. Just get rid of... No, actually, I can leave that there. That's not a problem. Just make ISR double fault and error, ISR new error. It actually, does that need an error or not? It does not have an error. So ISR no error 9. 9 is coprocessor segment overrun, which is does not happen anymore. So it is definitely an exception, and I can be confident that it's never going to happen normally. So I can make that say 9, and I can just run another interrupt 9, and I can be reasonably confident that that's not, like, that's my interrupt 9, that's something else. And then the only other thing I have to do is make sure that register IDT gate 9 ISO double fault stop hierarchies 0. Control Y crashes us again, which I think is good. I mean, it means that it doesn't work, but let's find... No, it's still looping vector 9s, so it's not actually doing what I was hoping it would do, which is just 9 exception, or 9 double fault. Like, it's sort of, I mean, it's getting me there because we are blowing the stack up, and so I'm ending up with this general protection fault, D, we had another general protection fault, so we got an OXO8. So, like, this should be exercising it should be moving the stack pointer, but it doesn't seem to be. I mean, I don't know why it's giving me a general protection fault. The problem with general protection fault, OXOD, is that just about anything can give you a general protection fault. Like, it's just bananas. Let me see if I can show the manual on stream. Intel 64 and IA32 Architecture Software Development Manual, Volume 1, 2A, 2B, 2C, 2D, 3A, 3B, 3C, and 3D, and 4. The 4,800 page document that contains all of the things that anyone would ever want to know about an Intel processor. New window capture. So now let's find the general protection fault. Interrupt and exception handling. So volume 3, chapter 6. Sources of interrupts, sources of exceptions. Where is it? Interrupt handling. No, I don't want handling. I want to know... want to know why. Why would I get a general protection fault? There's a list in here that contains like every conceivable reason why you would ever get I may not be able to find it on short notice. It's the whole section. It's been very helpful to me in the past to go through the list, because I'll be like, oh, that's something that I haven't thought about checking. But it's a 5,000 page document, so. Instruction set, no. Ah, here it is. Interrupt and exception handling, interrupt 13, the general protection exception. And here's the page-and-a-half list of all the things that can cause it. Exceeding the segment limit when accessing any of these segments, exceeding the segment limit when referencing a descriptor table, transferring execution to a segment that's not executable, writing to a code segment or a read-only data segment, executing or reading from an execute-only segment, loading the SS register with the segment selector for a read-only segment unless that comes from a TSS during a task switch, loading with a segment selector for a system segment, violating any of the rules described in Chapter 5. How's that for a... and of course now I've clicked off it, so I probably can't... Oh, I can go back. They fixed that. Loading the CR0 register with the PG, a cleared PE flag, referencing an entry in the IDT that is not an interrupt task or track gate. So I'm doing one of these things. I just have no idea what. Oh, and here's more for 64-bit mode. Yeah. Yeah. Pretty much. So I really want to do this in a way that doesn't cause a stack explosion. Like, I know that's the thing that we're trying to fix, but I really don't want to do, I guess maybe what we should do, instead of, let's go back to 127. Instead of trying to solve this by generating a double fault directly, by literally generating a double fault, maybe what we should do is put the stack pointer somewhere illegal, right? We're basically recreating the condition that we have when we run out of stack. Put the stack pointer somewhere that it can't be. And so when it's there, right, it has to move the stack pointer in order to be able to handle the it'll get a double fault, and then it has to move the stack pointer in the double fault in order to be able to handle it, and just print a message and then die, because the system's dead at that point. But I want to be able to get the debug info. So nav, like, not 0. Unfortunately, right, there's the very convenient that in programming languages, generally the address 0 is invalid. Unfortunately, I can't rely on that here because I think the address 0 is memory mapped. Actually, is it? I might have been very explicit not to map it. It can't hurt to try, can it? Let's just see if that might like just work. That's 127. Invalid register name RSP. Why? Shouldn't be. I mean, we just did this. Invalid register name. But it shouldn't be instantiated as %%. It's an ASM. Okay, let's go back to include auto. Oh, it's not an include. C syscall.c move thing to %% register. So why would that not be happy? Maybe I can, looks like you may not be able to move to the stack pointer. That seems kind of weird. But that should do the same thing? No. Well, that's not really. Let's just see if this works for RAX. No, it's not happy with that either. Why? Okay, well, I'm okay with moving it to ESP. I have no problem with that because moving any number into ESP clears all the top bits. I'm trying to put it to 0, so it doesn't really matter. Why? Okay, that said, coprocessor segment overrun, so there's a 9 somewhere. This is probably not the smartest idea I've ever had. Searching for 9. ISO double fault, ISO no error 127. Kernel TTY is the thing that needs to be 127. Control Y. Okay. That's encouraging. Where's the stack? This has actually done what I hoped it would do, which is print out there was a double fault. Fault occurred. It couldn't print out that there was the first fault because it didn't have a stack. RSP is 18 for some reason. That doesn't make very much sense to me at all. Unless page 0 is really there. which I guess I have to check. And is page 0 really there? It really shouldn't be. I guess I can check it this way. Kernel main, just like right as we turn everything on, volatile int x is null, well, is void star 0, printf star 0 is %I star 0, not star 0, star x. And that should fail. And it does. Fault reading data 0. So why? I like that it prints something out. Why is the stack pointer 18? I guess let's run this with -I and see. Hello, what the heck? Well, I think we found the problem. So I think my code worked, because this is the thing that would have broken, right? You remember we were moving up the stack, moving up the stack, moving up the stack, and then it crashed. And we weren't getting a print because it was triple faulting. Well, we got our double fault print, and here's our stack trace. So I think that worked. And the fact that that worked means I need to commit right now. Where is the code to put that? Show? Add double fault, interrupt endpoint. Okay, so we're gonna add because it's not PL1, we actually got that wrong. We're gonna just amend this commit. And this, we'll add it. So what I'm saying is, hey, I screwed that up. I'm gonna change that previous commit so that it says this now. And I don't think I ever put it on GitHub. I did not, so it's fine. I don't have to like force change it. So what's this doing? Why are we crashing? We're crashing because the timer says you should yield, so we try to schedule. Mutex lock, wait for, the timer says we should yield, so we try to schedule a new thread. In order to do that, we have to take a lock. That lock is apparently taken. So we try to wait for that lock. We block our thread. In order to do that, we have to schedule. So we try to take the lock that allows us to schedule. We wait for it, up the stack in an infinite loop until we run out of frames, and we die with a page fault. Page fault can't be handled because well, there's no stack to handle it on, so then it becomes a double fault, which was previously destroying the whole system. But now I have an extra stack for that. So now I know this. So now we know why we crash on boot sometimes. That's very productive. That's actually like super great. That's something that I probably should have done about 4 years ago. And the answer is, right, the why is this runnable lock, probably, right? That's the thing that needs to be taken in NQ. Well, let's schedule. Thread sched, next runnable thread, which, yep, takes the runnable lock. So this raises an interesting question, which is, what do you do about the runnable lock? Honestly, like, this has just got to be it just has to be a critical section. Like, you just can't get interrupted while you're holding the runnable lock. That's just all there is to it. That's something that I wanted to do in new mutex. We just seem to keep coming back to that today. I wanted to do that in new mutex. And now I have to decide. So I sort of have two options here. I can make a new mutex function that says, like, hey, take mutex and make it a critical section, right? So nobody is allowed to basically, right, what I want to do is I want to have a function that says take this mutex and also disable IRQs, and then when we release the mutex we re-enable IRQs. So we could do that as a separate series of functions, right? We could have like a, mutex lock critical, mutex unlock critical, or something like that. Or I could make it a parameter inside the mutex. The mutex could have like a flag that says, hey, when this mutex is taken, it's a critical section. And I like number one because that just makes sense and it's not stupid. Number two is bad, but it would mean that I don't have to change these instances right now. Like, I can just leave this with this wrapper without having to do anything. And I mean, really, like, I can just do this for right now. So the thing that I'm doing here, the reason doing anything with IRQs is necessary is the thing that tells the thread that it needs to switch is the timer interrupt, and so I'm just disabling interrupts for that period. It'll like queue the timer interrupt so that the next time, as soon as you say disable, the timer interrupt will happen. Which in this case is actually kind of problematic. I hesitated here a moment ago because I think this is a particularly problematic place for that to happen. And it doesn't matter because in this case, it already disables IRQ. So in this case, I don't actually have to care. Yeah, it would have been really problematic to say I can enable IRQs here, because you super can't enable IRQs here, because if you pull a thread off the runnable queue and you haven't marked it, you haven't returned it yet, like, oh, I don't want to think about the problems that are going to come with that now you've got this thread that's sitting there on the stack of somebody's next runnable thread, but it hasn't been run, but they're gonna, I don't want to think about that. But thread-sked, by the time you hit line 230, IRQs are always disabled. So it should be fine. So I would expect to never, well, I don't want to say never. It should be much harder for this system to randomly crash like it was doing before. That it'll just like start and just die. Because that was a triple fault, and now it should be much, much harder for this to get a triple fault. Because I'm actually setting up a stack to be able to print double faults. And of course, now that I've just said, hey, you know, we've really made some progress here, and this is good, this problem is back. The offset, the 1 byte offset pointer in sys right, that just doesn't make a lot of sense to me. Why would you have 1 byte offset? I don't know. What I do know is that I've been thinking about this for too long. And if I keep thinking about it, I'm going to start making mistakes. So I think I'm going to wrap this up here. I may be back on later, depending on how I feel after dinner. But for the moment, I think we're going to wrap this up here. So thank you, everybody, for coming along, and thank you for your questions. And I will see you later.